Hello guys, welcome to another episode of Jacob Dev. Today's topic is pyramid flow. One of the very popular options today for AI video generation. If you search for pyramid flow, and they should give you the GitHub page and like this. So it's basically on JY0205 pyramid flow. But if you go through their README, there's too many things in here that's overcomplicated. And if you follow everything they talk about in here, basically it's not going to be able to set up if you don't have a high-end GPU, which means maybe you need a 16 gig or more, maybe 20 gigs of VRAM, which is a lot of cost. And then what I'm talking about in this video today. In this video, I'm going to show you how to build it on Kaggle for free. So you can try everything out for pyramid flow at your own time and help you to build your video generation in your business. So that being said, let's get started. So basically, for the first one, they say I released the 7680p mini flux checkpoint up to 10 seconds, and we're gonna use the mini flux to demo everything we're gonna do basically talk to today. So they used to have a SD3 version, but anyway, so let's go to the Kaggle notebook. So if you look at the a few things that we have to build. First, we have to create a notebook for sure, like pyramid flow, mini flux in this case, and then we just use conda create, and we need to create a virtual environment because they support Python 3.8. So they don't support other versions as of now. If you go to their documentation, you can see that they only support Python 3.8.10. So we have to downgrade it because the Kaggle supports Python 3.10 by default. So we have to downgrade to Python 38 and to install a couple of packages from there. So from Kona Forge, PyTorch, and NVIDIA channel in Kona. So and then you have to install Python 3.8, PyTorch 2.1.2, and Torch version is 16.2, and Torch audio is also the 2.1.2. Torch CUDA is 12.1. So this is basically the conda dependencies, and also you have to activate the virtual environment. After that, just do a basically a soft link for all the different Python 38 environment to the conda default, because Kaggle is going to read from the conda default. So just follow these lines in here, so you should be able to basically link the Python 3 and also Python 3.8 configuration to the default conda environment. And after that, just make sure you also do a soft link to link the Python 38 pip to the conda pip as well. So also the pip3, and then because of the size of the pyramid flow, it's very big, so it's gonna cost about like over 60 gigs of disk space. If you look at the thing here, actually costs about 67 gigs, so it's quite big. Even though the max saying is 58, but it can go higher a little bit, so it's about like 67 gigs. So that's how big this project is. So just keep in mind, you have to switch the directories, because the default working directory, if you go to the working directory, it only has less than 20 gigs. So if you want to install more than 60 gigs of data, then you have to switch to Kaggle temp. So, and after that, just make sure that you include the virtual environment Python 38 paths to your system path, and also append the Python 3.8 set packages to the system path as well. Okay, so that's basically how to set up the prerequisite. And after that, just do a git clone for the pyramid flow. After that, make sure you install Gradle and requirements, because we want to demo this on Gradle, not the notebooks that they provided here, because the provided here is a little bit not exactly how this is gonna work on Kaggle, and you need to tweak a lot of things. So, but let's continue. So because we're gonna set up on Kaggle, and then because it requires also like more than 20 gigs of VRAM, how do you do it on Kaggle, right? And you have to do quantization. So of course you have to run quantization on different like text encoders and VAE and also transformers, so on and so forth. So first we install Optimum and Quanto, and we install Torchal, and then make sure that's under the CUDA 12.1. So, and make sure that you install these packages. And also, because we're gonna turn all this out to public URL, we're gonna demo this a little bit later, but because we're gonna turn everything out so you can access the public URL. Then you have the install ngrok. We demoed this many times, so check out other videos. I have a lot of explanations. So make sure that you install ngrok and pyngrok, and also make sure you have a function to run bash command within Python, and then you create a function to take the ngrok token. So then you can copy everything from ngrok console to here, so you have set up the local ngrok environment as you can see here. Basically set up in this path. So, and after that, make sure you point your ngrok public URL to localhost 7860, and then basically this is the public URL we're gonna demo today. So it's 84.450, right? So that's basically the public URL, and it's mapping to a Gradio localhost 7860. So then this function is basically if you have cache, and then you have to clean everything up because ngrok has a limit. So then if you actually exceed the limit, make sure you create this function to actually clean up the cache so you can restart again. After that, make sure you download the model. So you have to download the model from pyramid flow to first create a directory under the pyramid flow directory. This is basically what you clone from Git, right? Create another folder under that to store all the models, and then you also need to download the snapshot. So make sure to download this snapshot, which is the rain 1011 to pyramid flow minflux. We demo under minflux. So make sure that copy to this folder that you specified in here, right? So that after that, you need to change a couple of files to make this running on a 16 gig of VRAM. Actually, it's a lot less than that because of the quantization. So you can actually do more than what I demoed in this video, but let's see. So if you go to the this file, which is pyramid dit for video generation pipeline, update this pipeline so that it's under the pyramid dit. So it's under this folder. If you look at this folder, which is pyramid dit on this folder, change this file, the pipeline file, which they're going to use for the Gradio app. So then you can basically use the quantized model in there. And go to this import. So first you have to import the torch shell quantization. So import the quantize and make sure that you use 8-bit, so NT8 wait only, and make sure that you specify the quantization to NT8 wait only. And in the DIT section, build pyramid DIT, which is the transformer. So then you can actually just specify the quantized DIT. So this is quantized to 8-bit. So you can see the DIT. They can say if it's pyramid flux, then use this pyramid flux transformer. If you use the diffusion 3, I believe that's diffusion 3, and so then you can use this pyramid diffusion MMDIT. But any model, you can just do a quantization after that. And then for the text encoder, make sure you also run quantization here. So make sure if the text encoder exists, just quantize it to 8-bit. And also for the VAE, if you look at the VAE in here, so load VAE, basically make sure that you also quantize the VAE as well. You don't have to quantize all of them, but I just quantize all of them to see how much you can compress the data. So then after that, you can just continue with the other file. So this is the most important things that you have to update in the pipeline class. So after you so this is actually really big file, you can see. And after that, make sure you also update the app.py file. So make sure you change the model dtype to fp33. So because the Kaggle doesn't support the default bf16, which stands for the bfloat 16. So if you want to see what the bfloat 16 is, and also the comparison between the bfloat 16 and fp16, the actual 16, then you can just do a Google search, and then you can see that basically the bfloat 16 and fp32 have the same dynamic range. So this is very important. So but anyway, Kaggle doesn't support it, so then you have to use the fp32, so which is even bigger than the BF16. So, but you go back to the Kaggle notebook, so you can see that we have to specify that P32 instead of BF16 because this is not going to work in Kaggle. The Kaggle offers T4 and P100, so both they're a little bit older, outdated GPUs, but they works, but they don't support BF16. So change it to FP32. make sure this is updated. It's very important. And after that, just change the other. I think they all have a lot of the memory and storage optimization set up, but just check out every line. So see, for example, if GPU is available, and basically check if it's doing the CPU offloading. If it's not, then make sure that you do the GPU, use the GPU. So things like that. But I think the default is true. So basically it's gonna leverage the CPU instead of using the GPU. So there's a lot of stuff they already done, but make sure first you do the model D-type because to FP32, and then check all these different places to see if they have the variables or stuff set up. And after that, also make sure that you do this share equals to false because Kaggle doesn't support Gradle by default. So just make sure that shared equals false so you can actually link the ungrok to your local Gradle notebook. So that's it. So you change all that, and after that, make sure that you basically go to this Kaggle temporary directory and make sure go to not the default Kaggle working, but go to the temp directory, go to the primary flow, the git repo, and then do a python app.py, which is already updated. So you can see that's running on the port 7860. And after that, you can see basically already generated a few videos, which we'll demo in a bit. But you can see that everything is working. So I did a few videos to test everything, all the setup. So let's go to the Gradle interface. So you can see basically they provided a few samples for model resolution at 384 and also they provide 768, but the demos they actually provide as examples are on 384. So but we're gonna test all these demos to show this is working as expected. So if you just use the first prompt, so moving trailer featuring the adventures of the 30-year-old spaceman wearing a rat wool knitted motorcycle helmet and blue sky and salt desert and cinematic style and shot on 35mm film and vivid colors. So that's what it generated. Let's play it. So you can see that's actually doing really well. So on the 5-second video, which they only support 5 seconds for 384. So if you see the documentation here, they basically support 5 seconds to 384 and 10 seconds to 768. So, but the demos are only 384. So we're gonna demo the 384. You can try the 768 as well. So this is the first demo. The second demo is a beautiful snowy Tokyo city is bustling and the camera moves through the bustling city street. Let's go to the other tab to see the results. So they're already generated, so you can see the result here. So this is really good if you see that the generation of the video. So it's very it's an awesome look. And then the other one is for image to video generation. These are text to video, but also they support image to video. So I also did that as well, also to image to video, which is also on 384p. You can see that it's also generated very nicely. It only takes about less than 8 gigs for the entire generation process. Sometimes it's like 3 gigs, sometimes 8 gigs, depends on the process. If you go to the generated video, and let's click that. So you can see this is actually really, really nice. So this image to video, right? So previous demo text video. So you can see all the changes we made to the source code all works. So it works very nicely. And now you can actually run the parameter flow on Kaggle notebook. So instead of just using a virtual box of GPUs, and then you can literally just run everything on Kaggle. So that being said, hopefully this is helpful. And if you like this video, please subscribe, like, or comment if you have any questions. And thanks for supporting the channel. See you in the next one.